Right now, farther than any planet, beyond the fading glow of the sun, a lone spacecraft is traveling through one of the most hostile regions humanity has ever reached. Around it, the temperature is only a few degrees above absolute zero, a realm so cold that it seems impossible for any machine to survive. Yet Voyager 1 continues its silent journey, carrying on with a mission that began almost half a century ago. Launched in 1977, Voyager 1 was never expected to last this long. Engineers designed it to study Jupiter and Saturn before eventually falling silent. Instead, it exceeded every expectation. Today it has traveled more than 23 billion kilometers from Earth, crossed the edge of the Sun's protective bubble, entered interstellar space, and continues to communicate with our planet despite being farther away than any human-made object in history. That raises an astonishing question. How can a spacecraft built with 1970s technology continue operating in an environment colder than anything we experience on Earth? Why hasn't Voyager simply frozen into an inactive block of metal drifting endlessly through space? The answer is far more surprising than most people imagine. The mystery isn't really about Voyager. It's about our misunderstanding of what cold actually means beyond Earth's atmosphere. Here on Earth, cold feels aggressive. Step outside on a winter morning and the chill reaches your skin immediately. Your hands grow numb, your breath becomes visible, and your body rapidly loses warmth. It feels as though the cold is attacking you. But that's not what is really happening. Cold itself doesn't move into your body. Instead, heat is escaping from you. The air surrounding you is filled with trillions upon trillions of constantly moving molecules. Every time those molecules collide with your skin, they steal a tiny amount of heat. Billions of these collisions happen every second, carrying your warmth away until you begin to feel cold. This process is known as conduction, and it depends entirely on physical contact. That is why wind makes freezing temperatures feel even worse. Moving air constantly replaces warmer air around your body with colder air, allowing heat to escape faster. It is also why touching a frozen metal railing feels much colder than touching a piece of wood at exactly the same temperature. Metal transfers heat away from your body far more efficiently. Space works in a completely different way. The region Voyager 1 now travels through is almost completely empty. In every cubic centimeter around the spacecraft there may be only a handful of atoms. Compare that with the air surrounding you right now, where the same tiny volume contains billions upon billions of molecules. That difference changes everything. There is no icy wind blowing across Voyager's surface. No freezing atmosphere surrounds it. Nothing is constantly colliding with the spacecraft to steal its warmth. The spacecraft is floating inside an almost perfect vacuum. And a vacuum is actually a terrible conductor of heat. This means Voyager is not constantly being frozen by the coldness of space. Instead, it loses heat in an entirely different way. Every object with a temperature above absolute zero naturally emits infrared radiation. In simple terms, everything slowly glows with invisible heat. That glowing is how Voyager gradually loses energy. Unlike conduction, radiation does not require matter. Heat simply leaves the spacecraft as infrared energy and disappears into space. This happens much more slowly. Imagine placing a hot cup of coffee inside a cold room. Air quickly removes its heat and the drink cools within minutes. Now imagine placing that same cup inside a perfect vacuum where there is no air at all. Without air carrying heat away, the coffee would cool far more slowly. Voyager experiences something very similar. The coldness of space doesn't rush toward it. Instead, the spacecraft slowly radiates its own warmth away into the darkness. As long as it can continue producing enough internal heat, it remains alive. That is exactly how NASA designed it. Unlike many modern spacecraft, Voyager does not depend on solar panels. For missions near Earth, sunlight provides abundant energy. But every time you move farther from the Sun, sunlight becomes dramatically weaker. By Jupiter, the available sunlight has already dropped to only a fraction of what Earth receives. Near Saturn it becomes even dimmer. Far beyond the giant planets, solar panels would generate so little electricity that they would become practically useless. Engineers understood this before Voyager ever left Earth. Instead of relying on sunlight, they gave the spacecraft something far more reliable. 3 radioisotope thermoelectric generators, better known as RTGs. These remarkable devices contain plutonium-238, a radioactive material that naturally releases heat as it slowly decays. There are no engines, no flames, no moving mechanical parts. The plutonium simply produces heat continuously, year after year. Thermoelectric materials then convert part of that heat directly into electricity. The result is one of the most dependable power systems ever built for deep space exploration.